In this video, we're going to have a look at straight line graphs. Okay. Every single equation can be drawn on a coordinate grid. And vice versa, every single line on a coordinate grid has an equation that fits that line. That's the first thing you need to know. We're going to have a look at a graph with an equation y is equal to 2x plus 3. And we're going to try to put that equation on a graph. So how do you do that? Well, it's quite easy actually. You've done it before in the first chapter, or in the first part of this chapter. You're going to start by filling in your own values for x. So you're going to substitute. So for example, y is equal to 2x plus 3. Well, when x is minus 2, so I'm going to fill it in. What should my y be? Well, if x is minus 2, I get y is equal to minus 1. So that is my first coordinate couple, okay? So I have, when x is minus 2, y has to be minus 1 according to this equation. So that's my first couple of coordinates I have to plot or to draw on my graph. Let's have a look at a second one. So y is equal to, again, 2 times minus 1 plus 3. And I fill it in, and I get that y should be equal to 1. When x is 0, what do I get? 0 plus 3, that's 3. And so on and so on. So I just keep filling in x coordinates, and I get y coordinates in return. It does not really matter how many you do. You can do as many as you like, but I would advise for you to always have a few positives, always have a few negative coordinates, and always try and implement 0 as well. So this is what I get. Alright, so now my coordinates here, these, minus 2, minus 1, minus 1, 1, 0, 3, 1, 5, 2, and 7, those are the coordinates I am going to plot on my graph, or draw on my graph here. So I have minus 2, minus 1, that's right here. I have minus 1, 1, here, 0, 3, 0, 3, and then 1, 5, 2, and 7. See, this makes a very straight line, okay? Nice straight line. Let's plot that, or let's draw that straight line. Alright. Should look something like this. And voila. Okay. So this here is now my straight line. I'm always going to label my lines. So this is the line for the equation 2x plus 3. Now, these are linear equations. Again, you have different types of equations that will give you different types of lines on graphs. But for this one, this is a linear equation. It's just a straight line. Okay? Now, these equations always come in the form of y is equal to mx plus c, where m and c are both variables. And variables, that means they can have any kind of value you'd like. In this case, the example that we have on my graph here, okay, in this case m is 2 and c is going to be 3. So in this case m is 2 and c is 3. Now, we're going to have a look at two of the most important aspects of straight line graphs. The first one is going to be the gradient. And the gradient is going to tell us something about how steep a line is. So the gradient is always a number. It can be a fraction, it can be a whole number, it doesn't really matter. So that gradient is going to tell us how steep the graph is. Now, how do you find the gradient of any straight line graph? Well, first of all, you need to plot, or you need to find two coordinates on your graph. So I pick 0, 3 in this case. So 0, 3, I'm going to write them here. And let's take this one here, 2, 7. So I'm going to put this as my first coordinate here, first coordinate, and this is my second coordinate, okay? Now, you need to find how much you have to rise and run to get from one coordinate to the other. Okay, we always look at graphs from the left to the right. Okay, now when we look at this graph, this coordinate here is obviously the first one, and then this one here is the second. Okay, now how much do we rise and how much do we run to get from the first one to the second? That's going to be your formula, rise over run. So we rise and we run to get to that new coordinate. So you're always going to make sure that you make a straight line. Okay, imagine that you're stuck somewhere and you have to get from one point to the other, and the only thing that you can do is up, down, left, or right. Okay, so that's how you're going to try and figure it out. So from this point here, I run 0 to 2, I run 2 units, and I'm going to rise 4 units. So 4 over 2. So my gradient in this case is going to be 2, because it's 4 over 2. Okay. Now this is a way of doing it when you have the graph on there. Imagine if you don't have the line, if you don't have anything, if you just have 2 coordinates. How can you find a gradient then? Well, there's an easy trick actually. You're just going to, and you're going to have to use your coordinates for that. Again, you have 2 coordinates that are on the line, and you're going to find the difference between the 2 y coordinates, and you're going to find the difference between the 2 x coordinates. So y2 minus y1 over x2 minus x1. So in my case, that would be 7 minus 3 over 2 minus 0. Which, surprise, surprise, still gives you the same exact thing. So the gradient in this case is again 2. So first of all, gradient. So tell us how steep that graph is. Okay? Now, the second thing that we can also find is the y-intercept. The y-intercept is even easier, guys, because it's just, you have to look at your graph. That's it. You're going to look for the place or the coordinate where the line hits the y-axis. So as you know, the horizontal axis is obviously the x-axis and the vertical one is the y-axis. Let's have a look. Where does my line hit that y-axis? Well, here. So that means that my y-intercept in this case is going to be 3. And that's it. Those are the 2 main parts of a straight line graph. Now, but I would like you to go back to what we've just discussed a bit earlier. You know when I told you about y is equal mx plus c, and m would always be a variable and c would always be a variable? Well, guess what, guys? I just discovered that my gradient is 2 and my y-intercept is 3. But what do you notice? That's exactly the same thing as my m and my c. Exactly the same. So from my equation, I can already deduce my gradient and my y-intercept without even having to draw my entire graph. So, and that will always work. So m, in this case, will always be your gradient. That's without a doubt. And c, in that general equation, will always be your y-intercept, or where that graph hits the y-axis. Okay, so that's how easy it actually is once you know the general equation. Let's have a look at some of the exercises you might encounter when doing this chapter. For example, you have to calculate the gradient of each of the following lines. Well, again, gradient, you know that. It's equal to m, it's equal to rise over run. Well, in this case, in A, okay, let's pick a coordinate here. Let's pick this one and let's pick that one. Alright, I rise and I run. Okay, so run is going to be 1, 2, 3, 4. And I go up, so I rise 1, 2, 3, 4. So in the first case, my gradient is 1. Let's have a look at C. Let's take this one and that one. So for C, I run, I rise, 1, 2, 3, 4, 5, 6, 7, 8. So the run is 8, the rise 1, 2, 3, 4. So my gradient here is 1 over 2 when I simplify. It's perfectly okay to have fractions. You can also say 0.5, but that's really not that bad, okay? All right, now in question D, however, question D is a bit special. As I told you before, you always have to go from the left to the right, okay? So as you can see, if I take a coordinate here in D, for example, I take this coordinate, and I go to this coordinate, right at the end. You'll see rise and run are a bit different now, okay? So gradient is still going to be rise over run. In this case, you run 2. But rise is different now because you don't actually rise. You go down. You don't go up. So when you rise but you go down, that's actually a negative way of rising because you go down. So that's why this is going to be negative. So 1, 2, 3, 4, 5, 6. You rise negative 6. In other words, you go down. So it's minus 6 over 2, which is going to be negative 3. So it's perfectly okay to have negative gradients. That will just mean that your graph is not steep in going up, but it's going to go down, okay? Now, another example that you have to be able to do is finding the equation just by looking at a graph. How do you do that? Well, it's quite easy, guys. As you know, it's always in the form of y is equal to mx plus c. These are straight lines. It's perfectly okay. For the first one, the only thing we need to do is find m and find c. In the first one, let's have a look. Again, I've picked 2 coordinates, this one and this one. Let's have a look. All right, m is going to be rise over run. So I rise 4 and I run 4. So it's going to be rise over run. So 4 over 4. M is going to be 1. And what is C? Well, C is obviously, as you can have a look here, C, where does it hit your y-axis? Well, at number 2. So the y-axis, or the y-intercept, sorry, is going to be 2. So my equation is going to be y is equal to 1x, but I don't really write that. I'm just going to write x plus 2 for the first one. Okay, question B. Again, you look for m and you look for c. M is going to be, again, let's take this one, this coordinate, and let's take an easy one as well, this one. Okay, guys, always pick easy coordinates that have whole numbers as coordinates. Don't go and fidgeting about, just pick the whole numbers. All right, so I rise and I run. Let's have a look. I run 1, 2, 3, 4. No, not 4. 1, 2, 3. I run 3. And I rise 1, 2, 3, 4, 5, 6. So that's going to be 2. My gradient is 2. C, however, is not positive. It's going to be negative. My C is here. C is going to be minus 1. So that means that my equation is going to look like y is equal to 2x minus 1. Okay? My C in this case is negative, which is perfectly okay. Alright, guys. This is a very important chapter. Good luck on the exercises.